Okay, we're going to see if we can do one more example. This one's set up a little bit differently just with the instructions because it says a pirate paces 5 meters at 20 degrees north of east. Okay, what is 20 degrees north of east? I'm talking about this over here. And so we're going to go 5 meters in this direction. Well, how big is 5 meters? I don't know because I'm on a diagonal, right? You could skew your axes. I'm not going to do that right now, but that would be an option. So I'm going to call this vector A so we can keep things straight. I'm going to call this vector A. 5 meters, 20 degrees north of east. And then they go 9 meters west. So now they're going over here. I'm going to call this vector B. And 7 meters at 40 degrees south of west, what is the displacement from her starting position? So now she's going, let's see, 40 degrees south of west is going to be something like this. We call that vector C. So the question is, how far away from the starting position is she, this pirate? Okay. I don't know why, but it makes me think of the Backyardigans dressing up as pirates and going. So here we go. A, B, and C. What is the displacement? Notice I've gone tip to tail on everything. In other words, this has a tip, this has a tail, and then going to the arrow, and arrow, and arrow, and then my resultant is going to be this one here. Okay, we have to find every component. Let me tell you what I mean by that. We need to find A sub x, and we need to find A sub y. Then we need to find, well, B is easy, thankfully, but we can lay it out, B sub x and B sub y. Then we need to find C sub x and C sub y. Okay, let me tell you what I mean by this. The B is easy. In the x direction, the B went, wasn't it negative 9? So we can call that negative 9 meters, right? They went 9 meters to the west, so that's negative 9 meters. In the y direction, there is no y component of the B. It's just flat. There's nothing. So that's 0 meters there. What I'm talking about with these x and y components is I need to break these down into my components. So my components are, so for the A, for instance, I'm talking about this and this, the x component and the y component. So this part is A sub x, this part is A sub y. And those are the components of the vector. Okay, we need to know how long they are. I'm going to draw this bigger so we can see. We decided that that was 5 meters, right? And so we need to find A sub x and A sub y. And we knew that that was 20 degrees. So we need to do some trigonometry. I'm looking at the y and I'm thinking that's a sine problem. I'm thinking that sine of 20 is opposite over hypotenuse. That's A sub y over 20, over 5. So to solve my A sub y, I can multiply both sides times 5 and get 5 times the sine of 20 is equal to A sub y. I'm going to do that on my calculator. And I'm in degree mode. And I get 1.7. I'm just going to leave it as 1.7. Do you remember I told you at the beginning of the year that physics is not very concerned about significant digits? So keep it to a reasonable level. I think 1.7 with what we've got, 1.7 sounds good. Okay, A sub x, at this point I could either do Pythagorean theorem or I think it's actually faster to do cosine at this point. So I'm going to take the cosine of 20 is adjacent over hypotenuse. And so that's 5 times the cosine of 20 is equal to A sub x. So again, I'm going to do that on my calculator in the degree mode. And I get 4.69, we'll call that 4.7. So that's how I'm going to break it down into components. That's what I'm doing there, to break it down into my components. Let's look at vector C. All right, so here's my vector. It's 7 meters long. It is 40 degrees south of west. So let me draw some references for us. Let's say this is west. So this is 40 degrees south of west. So the way I have drawn it, that means that this theta is going to be a 50-degree triangle because we said it was 40 degrees out here, so it's 50 degrees in there. Okay, so once again, I'm going to rely on my trigonometry. I'm going to say cosine of 50 is adjacent over hypotenuse, or 7 times cosine of 50 is going to give me my y component, and I'm getting 4.5. Again, I'm going to go with my sine on the other one, and I'm going to say that sine of 50 is c sub x over 7. So 7 times sine of 50, and it's 5.3 or 5.4. Okay, let's think about direction a little bit. In the y direction, this one did go down, so let's go ahead and make the negative there. How have we been defining positive? I've been saying that this is positive, so I think we're okay leaving those positive. You just need to account for which directions you're going as you do this. Okay, I'm going to erase this part and we're going to go back and start adding all this together. So now that we have all the components, we can put it all together. So, like I know, okay, I feel like we need to go back and talk about that negative thing because let's go ahead and say to the right is positive and to the left is negative. So the A component is positive, but the B component is negative. We have that in there, okay. And then our C component, that's also going to be negative, right? In the x direction, it's going in the negative direction as well as the y. And the y, the A sub y, it's okay being positive. It should be positive. Okay, so we're good. So now, if I add up all my x components, I'm going to call that x total. Our total x is 4.7 meters plus a negative 9 meters plus a negative 5.4 meters. Negative. So I'm getting for my total, I'm getting a negative 9.7 meters in my x direction. And that, I'm just double checking, like logically, does that make sense? And I think it does. I think it does. So we're going to stick with that. And then our y components, I'm going to add up those y components, and I get 1.7 minus a 4.5. And I'm getting a negative 2.8. And I'm just hesitant because when I've done this in previous years, I got the same y component total, but my x component total was different. However, I think that this is the right thing, and you guys will let me know tomorrow if it's not, but I'm pretty sure that this is right. And so what we've done, these total things I've done, I've added up the components. Those are now the resultant vectors, like the components of the resultant vector. So what I'm saying is this piece is a 9.7 meter, and this piece is a 2.8 meter. And so now I can do the Pythagorean theorem with those numbers and come up with my resultant magnitude. And I'm getting a resultant vector of 10 meters, 10.01. Let's call that 10.1 meter. And I need to find out my direction. So my direction is going to be tangent, inverse tan. I'm just going to say tangent of theta is 28 or 2.8 over 9.7. So I can do inverse tan of that. And I'm getting 16.1 degrees. Okay, 16.1 degrees where? Well, you know what? I drew my arrow this way. The question is, what is her displacement from her starting position? So I think even though my arrow is drawn that way, because that's the way like that would complete the circuit, the question was actually asking the other way, right? Because it was her displacement from her starting position. So she is 10.1 meters away, and at 16.1 degrees, let's say south of west. Okay, I know that is a lot, and I know that's looks like a big fat mess, and it probably does, but the idea is we're breaking things up into components, x components and y components, and then we're adding those components together. Once again, if I made a mistake in here, one of you please speak up and let me know, because we need to fix that if I did, but I'm actually feeling pretty good about it. So I'm going to stop the video there, and we will continue talking about this in class.